Today I'm going to show you how to use Proteus design suite to do an experiment on bipolar junction transistor common emitter output characteristics. If you want to see how we did the input characteristics, click on the link below on the description and you will be able to watch that. So today this is the circuit that we are going to use. Remember that we are going to use BC107, that is a transistor, 100K resistor, 1K resistor. We will require two voltage sources, VBB, VCC, at 0 to 30 volts. We'll require a voltmeter and an ammeter. So let's get to it. So click on the schematic capture. And this is the schematic capture. So one thing to do is to start bringing in your components. So click on the component mode, click on P to pick the components. One of your component is BC107, search on it, click OK. Pick another device which is a potentiometer, POTHG, click on it, click OK. You will also need a resistor, so click on resistor, click on resistor, select one of these resistors, select 1K 10 watt resistor, click OK. You will also need a DC voltage source, so click on pick, search for DC source, DC voltage source, so select V source and click OK. Those are some of the components. Of course, you'll require other components. So let's get started. Click on the BC107, go to the schematic capture, click anywhere to place your transistor. So that is our transistor. We will, according to our circuit, we require an ammeter connected to the base, and we will require the resistor connected to the ammeter, and of course now the voltage source. So let's do that. So click on this icon here and select DC ammeter to connect your ammeter to the base. Connect your ammeter to the base, and from there you will require your resistor. So go back to components mode, click on this, place your resistor here. So remember, you will require one. Let me expand this. This ammeter here will measure the current IB, so you can even label it as IB. And of course, the currents will be measured in microamperes. You can change that. That is done by just double clicking on this. For the resistor R1 here, you require 100K resistor, so just edit like that. Okay, so from here you need your potentiometer, place it here. Okay, you can drag a little bit further. The slider is connected to the resistor, and the two terminals are connected to the V source. So click on the V source and place it close to the potentiometer. Then connect the two terminals to the potentiometer like that. Okay, then the emitter here is connected directly to the ground, so you can do that. So at this point you have done the connection at the input circuit, so this is quite okay. So you want to do now the connection at the output circuit. So here you will require an ammeter according to the circuit. You will also require a voltmeter, you require a resistor and voltage. Okay, so go back to the Proteus, and before we do that, remember the voltage source that you require here is from 0 to 30. So you double click on it, change 1 to 30 volts, and you can even rename it. Remember, this one is VBB. You can rename it as VBB in that manner. Okay, so let's go to the output circuit. We require an ammeter, so we click on DC ammeter, and we need to reverse the terminals to this one. Okay, we need to reverse the terminal. So click on the DC emitter, click on the X mirror, such that you are making the circuit to be reverse biased. The output circuit must always be reverse biased. You're connecting the negative to negative. Remember, this one is an NPN transistor. Okay, so this emitter here will measure the current IC. So you can label it as IC, and remember to change the units to milliamps. IC. Okay, IC. So we also need a DC voltmeter to measure the voltage VCC. Okay, so this one will measure the voltage VCE. You can even rename it VCE. Okay, so from here you need a resistor. So go back to components mode, click on 1K resistor, connect it to the positive terminal of the emitter and the other terminal to the potentiometer, which in this case you need to X mirror it, need to turn it around. So you need to connect this to the slider and the other two terminals to the voltage source. You also need a voltage source. In that manner, connect the two terminals of the potentiometer to the positive and the negative terminal of the potentiometer. Then connect to complete the circuit. So we are done with our circuit. So our circuit will look like this. Okay, but of course our voltage here VCC should be at 30. So let me also put it to 30 volts. You can name it to VCC. Click OK. Great. Okay, so for this measurement, you are going to keep the current IB constant while you note the changes between the voltage VCE and IC. And we are going to fill this table down here. I'm going to fill this table. Okay, so I'm going to skip IB is equal to 0. I'm going to start with IB is equal to 20 so that we see the values and then we plot a graph to see the relationship. Okay, so let me go back to the Proteus. We will have to run the circuit. Click on run and you will be able to see some values. You will see some values. So to start with, we are going to bring these values to 0, all of them to 0, by adjusting the potentiometer to 0 and also this other potentiometer such that IB is 0. We are going to start by setting IB is equal to 20 or something close to 20 by adding this value. So I'm not going to get exactly 20, so I'm going to use 21. That is why I have 21 here. And that value will be kept constant throughout as you collect the values of VCE against IC. So as you can see, when the VCE is 0, IC is also 0. So you can start by that, record 0, 0. Then you can increase by intervals of 2. So adjust this one by adding. So we can, of course, go to 1 first, and then we go up by steps of 2. So let me start with 1.20, 1.20, or simply 1.2. And I'll note the current IC. So the current IC is 4.61. So I'm going to record that, 4.61. Then I'll increase the voltages by 2. So by 2, I'll go 1 plus 2, that will be 3. So let me go to 3. So I'm not going to exactly get 3, so I'll use 3.2, 3.2, and then note the current IC, which is now 4.79, 4.79. I will increase the current also by 2 to something close to 5. So I'm going to use 5. Let me see whether, yes, let me use 5.25. 5.25, and for this I'll get the current at 4.98. 4.98. I'll go to 7.07. Then I'll note the current. The current is 5.15. 5.15. I'll go to something close to 9.22, and then I note the current IC, which is now 5.35. 5.35, and then if you increase this by 2, we'll go to 11. So go to something close to 11. Let me use 11.1. Then I note the current. The current is 5.53. 5.53. And then I go to something close to 13. Something close to 13.1. Then I note the current, and the current in this case is 5.71. 5.71. Then I go to something close to 15.2. Then I check the current. The current is 5.9. Then I go to something close to 17.0, and the current in this case is 6.07. Then I go to something close to 19.1. Then I note the current, which in this case is 6.27. I go up to 21. So I get exactly 21. I note the current, which is 6.45. Then I get to 23.3, which is actually the highest. And the current is 6.67. 6.67. So I'm going to delete these two columns. So that is when the current is kept constant. At the current IB is kept at 21. So you are going to see the relationship between these two values. So I will copy this one, paste it in an Excel, and see the relationship. So I'm just going to use a simple line graph. And that is it. So you see, that is the output characteristics. That is the output characteristics of BJT common emitter transistor. Okay, you can do the same by adjusting IB to 40 by just repeating the same experiment, and note the relationship between the VCE and IC.